This is an exam question about the periodic table, group 7, the halogens, and covalent bonding. So it says, which group in the periodic table is known as the halogens? And we've got a choice of group 1, group 2, group 7, group 0. So group 1 are the alkali earth metals. You may have seen them reacting with water, and when they react with water, they produce sodium hydroxide, which is alkali. So that's why they're called alkali earth metals. Group 2 are the earth metals. Group 0 are the noble gases. They do not react with other elements. And group 7 are the halogens. So we'd therefore tick group 7. Next part of the question. Says fluorine atom has 7 electrons in the outer shell, so that's important. The outer shell holds 8 after the second shell. Figure 8 shows part of a dot and cross diagram to represent a molecule of fluorine, F2. We've got to complete the dot and cross, so it's important that we use dot and crosses. You should show only the electrons in the outer shell, so we don't have to show the electrons in the shells that are below this outer shell. Part of the diagram's been completed for us, and it's put 2 electrons in pairs. First one represented with dots, second one represented with crosses, and they represent the electrons. So the first bit of information says it's got 7 electrons. They want to get to 8. So that means these 2 fluorine molecules will have to share an electron, and that's why we've got the shells crossing over. Each fluorine needs to gain 1 electron. They've got 7. They want to get to 8. They've got to gain 1 electron. So this first fluorine, represented with circles, it will therefore share 1 electron because it wants to gain 1 electron. And same with the other fluorine because they're both exactly the same element. So they both share 1 electron. We've now drawn 1, 2, 3 electrons for this fluorine. We know it's going to have 7 circles altogether. So 1, 2, 3, 4, 5, 6, 7. We've now drawn the 7 electrons on the first fluorine atom. Second fluorine atom, same again, but this time represented with crosses. So 1, 2, 3, 4, 5, 6, 7. And then because they're both sharing 1 in total, and you count these being in each fluorine atom, each atom has now got 1, 2, 3, 4, 5, 6, 7, 8. And this fluorine atom, 1, 2, 3, 4, 5, 6, 7, 8. That's what we wanted to get to. So 2 marks, 1 mark for drawing the electrons that are shared, and 1 for drawing correctly the remaining outer shell electrons.